Hi, everyone. So let's start the session now. We warmly welcome all of you all for the 18th community call held by the WSO2 API Manager team. We hope everyone is doing well. And I'm Kavishka, and I will be talking today about the new way of deploying APIs across a cluster of gateways. This is an open forum, so all questions are welcome. You can ask questions either via the chat during the presentations or unmute at the end and have a discussion with the WSO2 API Manager team and the rest of the community as well. The recording of this session will be uploaded to our YouTube channel called API Live. Also, our YouTube channel has our previous community calls as well, which includes various topics related to API Manager. In case you have missed any of the previous topics, you can head over to our YouTube channel and have a look at these topics as well. I'm Kavishka Fernando. I'm a senior software engineer from the API Manager product team. And today on the agenda, we will be discussing about runtime artifacts, architecture of the inbuilt artifacts synchronization model, configurations that are related to this the inbuilt artifact synchronization model, and I have a small demonstration prepared for you so that you all can have a hands-to-hand look about how this inbuilt artifact synchronization feature works. So in terms of runtime artifacts of the gateway, we have our APIs, sequencers, local entries, and endpoints. These are all API Synapse artifacts related to a specific API. Sequence attached to APIs, the local entries related to the APIs, and the endpoints that relate to the APIs as well. So currently, in a multi-gateway environment, Synapse artifacts such as our sequence, local entries, and endpoints are usually saved as XMLs in the file system, or also in the direct. You can find these XMLs in the API Manager home repository deployment server Synapse configs default file. So I'm sure most of you all would have seen the XML files related or the Synapse files related to your APIs inside this default directory. So these artifacts usually have to be synchronized between all the gateway nodes using an artifact synchronization mechanism. So in an API Manager gateway cluster, artifact synchronization is generally critical to maintain consistency among the various gateway nodes that you have in your cluster. So if we have a multi-gateway setup, we usually use a NFS or rsync file-based artifact synchronization methods. So these are file synchronization mechanisms to synchronize the artifacts in between your gateway nodes. So when using a file-based system, such as the synchronization, as your synchronization mechanism, you need to mount the server directory. The server directory, which is found in the API Manager home repository deployment folder, you have a server directory. You need to mount this server directory to the two nodes of your shared file system so that you can share all the APIs and the throttling policies between all the nodes. So this can be sort of troublesome. So there are other issues that you get when using NFS to synchronize your data. So NFS depends on a server mounted in a remote machine. So that is an additional dependency. So NFS clients run on each gateway virtual machine as a service and can cause issues to the running gateway processors. So NFS will also sync any changes done to the remote servers, the files in those servers in real time without doing any sort of validation. So in case one artifact gets corrupted, all the gateways will have the corrupted file as well. So current NFS is not a managed and a highly available service. So with API Manager 3.2.0, we have introduced an event-driven mechanism in order to synchronize these gateway artifacts. So we have introduced this inbuilt artifact synchronizer because there were some limitations with the existing file-based synchronizers like I mentioned before. So what is the exact issue that we try to solve by introducing this inbuilt artifact synchronization feature? So in a file-based synchronizer, if one of the artifacts gets damaged or corrupted, it results in all the artifacts getting damaged because there is no validation. So with the new implementation, as I will explain further in the following slides, we store our artifacts in the DB. So the artifacts will not get corrupted even if it's damaged by one of the gateway nodes. So another reason for moving out of NFS is due to containerization. So persistent volumes aren't highly recommended, and depending on shared persistent volumes always makes deployment a bit more complex. So hence why we have introduced this inbuilt artifact synchronizer. So let's have a look at the architecture of our inbuilt artifact synchronizer. So if you have a look at this, you can see that the components that are involved to this feature is the publisher, traffic manager, gateway, and we need some sort of storage. So there are two extension points that are necessary for this feature: the publisher extension point, which is found in the publisher node, and the retriever extension point, which is exposed in the gateway node. So what happens in this scenario is when we publish or edit an API, the publisher will create the Synapse artifacts relevant to this API and store it in the storage. So the storage could either be a database or it can be a version control system of your choice. So the publisher will save these artifacts in the storage and then will send an event to the traffic manager with the details of the specific artifact. So there can be two types of events when they're publishing an event. It can be an API publish event or it can be an API remove event. So the specific event will be sent to the traffic manager using event notifiers, which includes the API UUID, the tenant ID, the gateway instruction saying whether it's a publish or removed event, and the set of gateway labels that are necessary for the API. So the gateway labels is a concept that we are bringing in with this artifact synchronization, the new inbuilt artifact synchronization model. So the gateways are subscribed. The gateways can be subscribed to the traffic manager. So with gateway labels, what we do is a gateway can subscribe to multiple gateway labels. So what happens here is if a gateway is subscribed to a gateway label, then the gateway will filter out the events. Now, once the publisher publishes the event to the traffic manager, the gateway will filter out the events based on the subscribed gateway label. And if the specific label is available, it will retrieve the artifacts from the storage and deploy it in the gateway. So the gateway label concept is something similar to the environment name that we already have existing in our system. So if you're defining multiple gateways, you provide an environment name. So gateway label has a similar concept like that. So in our default implementation, we have used a database as our storage, and instead of directly connecting the gateway to the storage system, we have used the traffic manager internal APIs to connect to the database and retrieve the artifacts. So the publisher will publish the artifacts to the database and then publish the event to the traffic manager. Then the gateway will filter out the events by the gateway label, and the gateway requests for the artifacts from the traffic manager's internal API. Then the traffic manager will retrieve the artifacts from the database and the gateway will deploy the API. So this is the scenario that happens in the flow of the inbuilt artifact synchronization. The publisher publishes the artifact to the storage, and then the publisher in return gives an event to the traffic manager. The gateway filters the event based on the gateway label and requests for the artifact, and the traffic manager retrieves the artifact and provides it to the gateway, which in return deploys the API. So at startup, what happens at the startup in this inbuilt artifact synchronization scenario? So at startup, the gateway will look for the APIs with labels that it is subscribed to and fetch the Synapse artifacts of those APIs through the retriever extension that we have created. So those Synapse artifacts will then get deployed in the gateway. So in order to do this, our implementation in the default implementation with the database is that we have used the traffic manager internal APIs to retrieve the artifacts from the database. So gateways are subscribed to the traffic manager. So there is an extension in the gateway to get the Synapse artifacts and deploy them in memory. So gateways can subscribe to multiple labels as well. So there are a few special points that we need to keep in mind when we are thinking about this inbuilt artifact synchronization model. So this is an optional feature. It can be configured through a configuration in the deployment HAML. So in API Manager 3.2.0, in API Manager 3.2.0 only we have introduced this feature, but still the default is still the file-based artifact synchronization method. So if you want to use this inbuilt synchronizer, which we recommend for large deployments and containerized deployments, then you have to enable this configuration in the deployment HAML. So we will discuss about the configurations a bit later. So once we enable, the next point is that once we enable this feature, the Synapse artifacts will no longer get saved in the artifact directory. So I will show you in the demo how the gateway nodes that are external gateway nodes, once we enable this feature, you won't be able to see the artifacts in the file system. That's in the Synapse configs folder, you won't be able to see the artifacts anymore. So what we do here is in this feature, we save those artifacts in the storage. So with our default implementation, what will happen is it will get stored in the database. The third point we have to keep in mind is we have the ability to change the storage based on the two extensions that we have introduced, which one is the publisher extension and the other the retrieve extension in the gateway side. So it can either be a database or you can also use a GitHub implementation as well. So the next point is one gateway can subscribe to multiple labels. For example, if my gateway has subscribed to label 1, label 2, and label 3, all APIs that are published to label 1, label 2, and label 3, all these artifacts will get synchronized in my gateway as well. In case, so for example, think I have API 1, API 2, and API 3. API 1, I subscribe, publish it to label 1. API 2, I publish it to label 2. And API 3, I publish it to label 3. In this scenario, think my gateway has subscribed to label 1 and 2. And once I publish API 1 and API 2, the artifacts of API 1 and API 2 will get synchronized in my gateway because it is subscribed to label 1 and 2. But if my if the API 3, since it's published to environment or label 3, and my gateway is not subscribed to label 3, this API 3 artifacts won't get synchronized in my gateway. So the gateway labels, like I mentioned before, are quite similar to the environment names that we have when we define multiple gateways in our deployment HAML. So when we are publishing an API, we have the opportunity of selecting which gateway labels we want to publish to. So previously also we were able to select which gateway environments we could publish to. So the same way we can select now which gateway labels we want to publish our API to. So from the gateway point of view, we can subscribe to the gateway label that is created from the admin console or the environment names that we already have. So in case you're wondering how we can create the gateway label, we should use the admin portal to create our gateway label. I will show how to create a gateway label in the demonstration as well. So the final point that we have to remember is, since we no longer have the file-based artifacts in our file system, we have introduced a new gateway REST API So with this REST API, we can deploy or redeploy or undeploy our API. We can also retrieve our API artifacts, Synapse artifacts. We will have a look at this gateway API as well. When considering the database, by default, we store the artifacts in the AMDB. You can point to a new database if needed. We will see in the next slide how we can do that. So there are two data tables related to this feature. The first being AMGW API artifacts, which is API Manager Gateway API artifacts. This stores artifacts against the API ID. So we use a blob to save the gateway artifacts. We use the API ID and the gateway label to map these artifacts. The next table that we have is the AMGW published API details, which is the API Manager Gateway published API details. And this table is used for gateway REST API operation. As you can see in this, our primary key is used as the API ID, and we use the API ID and the gateway label to map these. So in case you want to use an external database, so if you want to have your artifacts in a different database or in another place, so you can add the following configuration, which has the sync runtime artifacts DB configuration related to the database. You can give your database type, your URL, the connection URL, your username and password. So you need to add the tables AM Gateway API artifacts and AM Gateway published API details to your new database. The scripts to create these tables can be found in the API Manager Home DB scripts API Management directory. So now let's have a look at the configurations. There are two main components when it comes to the configuration. We have to do configurations in the publisher node, and we have to do configurations in our gateway nodes. So let's have a look at the configurations that we need to do in our publisher profile or the publisher node. So if you have a publisher node running, you need to stop the publisher node. You need to add the following configuration in the deployment tunnel, which resides in the API Manager Home repository conf file. So what happens here is we'll discuss about each configuration bit by bit. So the APIM sync runtime artifacts publisher configuration element, it defines that all the artifacts will be saved to the storage via the extension point. By default, they will get stored in the database. The next configuration is the artifact saver configuration. It specifies the extension point, and the default is the DB saver where the artifacts are saved in the database. The third configuration that we have is the publish directly to gateway. So if publish directly to gateway is true, then the artifacts will be published to the gateway directly. If publish directly to gateway is false, then published API details will be notified to the traffic manager through events, which will be using the event driven. So if in case we add our gateway configuration as well to an all-in-one node along with publish directly to gateway true, which I will show in the demo as well, it will publish directly to the gateway through our admin service, and it will also trigger an event in the traffic manager. If you make publish directly to gateway false, this will only notify the published API details will only be notified to the traffic manager, hence using the event-driven system. So you can add the gateway labels from the admin portal. There's a gateway label feature that you can add in the admin portal, which I will show in the demo. You can go there and add the gateway label by providing the name, the description, and your gateway URL as the host. Now, let's have a look at the gateway configurations. So if you have, you need to add these gateway configurations to all your gateway nodes. So if you have your gateway nodes up and running, you need to stop them, and then you need to add this configuration to the deployment YAML file of your gateway node, which resides in APIM home repository conf deployment YAML file. Let's discuss about each and every. So here, as previously you saw, this is the APIM synchronization runtime artifacts related to the gateway. In the previous one, we had APIM synchronization runtime artifacts related to the publisher. So for the gateway, the first configuration we have is gateway labels. Here you can see multiple labels that are available. So the gateway label is where we specify the labels that the gateway is going to subscribe to. So only the APIs with these labels will be pulled from the extension point and deployed. Like I explained before, if your gateway is subscribed to these labels, any API that is published to these labels, these artifacts will get synchronized in your gateway. In case you haven't subscribed to a label, the artifacts that are published to that label will not get synchronized to your gateway. So the next configuration we have is the artifact retriever. So this specifies the extension point. The default is the DB retriever, where the artifacts are pulled from the database. So as you remember, we said that there are two extension points. The where here we have in the gateway side we have the artifact retriever, and in the publisher side we have the artifact saver. So the artifact saver in the publisher side goes as DB saver, and the artifact retriever goes as DB retriever in the gateway side, specifying that we are retrieving from the database. So then we have the deployment retry duration configuration. In this configuration, we are going to specify the retry duration in milliseconds to deploy artifacts if there is a failure in pulling them from the extension. So we use the deployment retry duration configuration. The retry duration specified here will exponentially increase by a progression of factor of 2. So thereby the duration will increase as 15 seconds, then 30 seconds, then 60 seconds, 120 seconds, and so on and so forth, if there are continuous failures. So the retry duration is usually bounded by about 1 hour. So this deployment retry duration is applicable only in asynchronous deployment mode, where the server will try to deploy the artifacts after it is started. So the next configuration that we are going to discuss is the data retrieval mode. You can either use synchronous or asynchronous mode. If you use the data retrieval mode as sync element, you can use this to specify the mode of deployment of artifacts from the extension point. By default, the gateway startup will be in synchronous manner, where the server will wait until all the APIs have been deployed. If there are any failures in the deployment process, it will be triggered again for n number of times, where we consider n as the maximum retry count. So if the APIs are not deployed even after the maximum number of retries, then the server will start with undeployed API artifacts. So if we need to switch the startup mode to asynchronous mode, then we need to specify the configuration for the data retrieval mode as async. In an asynchronous mode, the server will be up and independent of the deployment of the Synapse artifacts in the gateway. And the final configuration that we have is the event waiting time. So this element can be used to specify an event waiting time in milliseconds for the gateway. So the gateway will wait for the time specified in this configuration after receiving an event. So this ensures that artifact retrieval is not ahead of the artifact updates in the publisher. So by using this configuration, we can avoid inconsistencies. So the default waiting time will be 1 millisecond. So for the demonstration, let's just think of a use case where a user has 500 plus gateways and needs to synchronize the artifacts between these multiple gateways. So he has connected a new gateway cluster to his environment, and he needs to synchronize the artifacts to this new gateway. And in the way, he has to go and republish all these APIs to the gateway cluster. But we'll see how we can do that with the new inbuilt artifact synchronization. So what I'll first do is I'll show the configurations that I have done. So my deployment includes one all-in-one node, which has my publisher, traffic manager, and the gateway as well. And then I have a gateway worker node configured. So in my publisher node, I have added the publisher related configurations, specified the artifact save as DB saver, and I have set publish directly to gateway true. So this is the publisher related configuration. When I look at my gateway node, what I have done is I have added the gateway related configuration. Here I have subscribed to label 1 and label 2, and my gateway is subscribed to label 1 and label 2, and the retriever is specified as DB retriever. Something that you have to remember is the gateway node should point to your traffic manager, because we are sending the request to the traffic manager to get the artifacts for us for the specific gateway. So you need to point all your traffic manager related URLs to your traffic manager node. So these are the configurations that you need to do. So hope you all can see my terminal. So this is my all-in-one node, and my gateway node is in my next tab. So what we'll first do is we'll log into the admin portal. And here on our newly revamped admin portal, you can see multiple options here related to throttling policies, categories, key managers. So what we need here is the gateway labels. If you all remember, previously in our admin portal, we used to have this micro gateway labels option. So it is that same option that we have provided to add a gateway label as well. So now we are going to add a new gateway label called label 1. And we can add a description. And I am going to add my gateway URL here. I'm going to save. And I'm going to create another label, label 2. And I'm going to provide my gateway URL. Now we have successfully created 2 gateway labels in our admin portal. Now what we'll do is we'll first deploy the sample API. As you all know, if you have used a default API manager pack, if you deploy the sample API, it by default gets published to the production and sandbox gateway environment that we have specified. And then I will create another API, and let's specifically publish it to the 2 labels, and let's see the difference. So I am going to, let me put some enters here so that we can see the difference. So what I'm going to do is I am going to deploy the sample API. Okay, and the API has been published. If we go to the environments tab, we can see that the production and sandbox environment was selected and published, and you can see the newly created gateway labels that are available here. Now, if we look at the logs, we can see in the all-in-one node log that our Synapse artifact has been added successfully to the all-in-one node. But if we look at the gateway node, it has not been added to the gateway node. That is because I did not subscribe to the production and sandbox label in my gateway configuration. As you remember, I have only subscribed to label 1 and label 2. Now, we will create a new API. We will create a new API called test context text. Let's provide a and I am going to create this API. And now I am going to go to the environments tab, and in the environments tab I'm going to select label 1 and label 2 and save. So now my API is going to get published in label 1 and label 2 as well. So let's go to overview and publish the API. Now my API has been published. As you can see in my all-in-one node, you can see that test API has got deployed and the Synapse configurations have got added successfully to the all-in-one node. Let's have a look at the gateway node. If you have a look at the gateway node, now you can see that the artifacts have successfully got added. So the local entries, the endpoints, and the API have got successfully added. So this is one way in which we can confirm that the artifacts got synchronized to our gateway. So if you further want to verify that whether your artifact got synchronized, one thing we can do is we can retrieve our artifact and view whether this has been whether this artifact has been synchronized. So now we will have a look at our gateway API that was newly introduced with API Manager 3.2.0. So this is the new gateway API that was introduced to API Manager 3.2.0. So with this API, you can redeploy your, there are 3 resources. So you can redeploy your API. This operation is used to redeploy an API in the gateway. So you need to provide your API name, the version, and the tenant domain. So in case that the tenant domain is not provided, the API will consider it, the tenant domain, as Carbon Super. So you can use this resource to redeploy your API. If you want to undeploy your API, you can use the undeploy API operation, where it will undeploy the API from the gateway. Here, to undeploy your API as well, you need to provide your API name, the version, and the tenant domain. Here also, if you don't provide the tenant domain, it will be taken as carbon.super. So this is the artifact that this is the resource that I'm going to use and show you all how we can retrieve the API from the storage. So we have our API, we have to provide the API name, the version, and the tenant domain. Let's see how we can do this. So this is my API request that I'm going to use. So I have used basic authorization with admin, and I have pointed to my gateway node, the specific gateway node that I want to retrieve the artifact from. And I'm calling this API with API test version 1.0. I'm not providing the tenant domain since it's a Carbon Super user. So now we can see that our artifact got successfully retrieved, and now you are able to successfully see your artifact from the API retriever resource. So this is one way that you can verify that your resource is there as well. Now what we can do is we'll have a look at the file system. We'll have a look at the file system and see whether the files are still available or not. So first we will navigate to the gateway node, to repository, deployment, server, Synapse configs, default, API. Here you cannot see the new test API that we have deployed, or the new the artifact related to the test API that we have published. So if we go to the all-in-one node, here we can see both APIs that we have published. The reason for this is I did not add the gateway configurations to my publisher node. So if you look at the publisher node, it has its internal gateway as well. So if I want this, if I don't want the artifacts in locally to be shown locally in my file system, I need to add the gateway related configuration to my all-in-one node as well. So if I added it to my all-in-one node, the gateway related configurations, and I subscribe to the necessary labels that I need to synchronize the internal gateway as well, and up the server, and I have to then if I set the publish directly to gateway as false as well, because I don't want to trigger two events for this. I don't want it to publish through the admin service as well as through an event through the traffic manager. So I can set it to false, and add the gateway related configurations in this node as well. Then all the Synapse artifacts in the future will not get saved in this node as well. So this is the demonstration I had lined up for you all. In case we have a few in case you are wondering whether we need to have a direct database connection to the gateway nodes, in this scenario, we do not need to, with the new inbuilt artifact synchronization, we do not need a direct connection to the database, although we are retrieving artifacts from the database. What we do is we retrieve these artifacts through the traffic manager. So since we do this, we do not need a direct database connection to the gateway. Also, when it comes to performance, we did see a significant performance in the startup, as it's much faster than a file-based system. Since we recommend this feature for large deployments with multiple gateways and for containerized environments, you will be able to see an improvement in the startup time as well. Now we will open the floor for questions. You can ask us questions over the chat, or you can unmute yourself and ask questions. The floor is open for the questions. So in case we don't have any questions, let me discuss some frequently asked questions or frequently asked issues that people have with this feature. So so customers have asked us what are the advantages of this inbuilt artifact synchronizer. So the gateway becomes very easily horizontally scalable with this feature. So previously, you needed to republish this API to multiple gateway environments in order to publish this API artifacts to the various environments. But now all you need to do is subscribe your gateway to the specific label and start the gateway node, and the artifacts will get synchronized. So another question you all might be having is what happens when an API gateway is freshly started with a given label. So what happens here is the artifact retriever will look for the APIs published to that label, and then it will retrieve the artifacts and deploy it in the gateway. So if there are no labels or no APIs deployed to those labels, the gateway will not have any APIs deployed. So if you are also wondering whether we have a previous NF file-based system synchronization, yes, we have not removed that. That is still our default artifact synchronization method. It's the default artifact synchronization method. So if you want this inbuilt synchronization feature specifically, you need to go to the deployment tunnel and add all those configurations that I mentioned. These configurations are readily available in our documentation. So you can have a look at our documentation and try it out. Okay, and then we had a few questions. Seems like nobody has. Does anyone have questions related to this feature? Okay. Since we have no questions, I will answer two questions that were brought to us from the submit form. So one was, please propose a solution for deploying different APIs on external gateways differently from internal gateways. So what we assume you want to do is publish APIs to different gateways as per your requirement. So what you can do is you can define, if in a normal gateway environment, you can define multiple gateway environments, or in this manner, you can define gateway labels, and you can, when you're publishing your API, you can select the necessary gateway that you want to publish your API to, and then go ahead and publish your API. So this will help you to selectively decide which APIs are getting published to or deployed in which gateways. I hope we answered your question. And another question that was brought to us was, we need to know if this license, so they want to use it for commercial use, or if a license has to be obtained to use our WSO2, a WSO2 product. If you download the package to the WSO2 website, you need to get a subscription to deploy it in production, and also in pre-production in production. So in pre-production environments, you can use it for about 15 days. So if you want to use our products commercially in a production environment without having subscription, then you have to download our product through GitHub. Um, do we have any further questions? So we have one question asking us about how we can persist artifacts in Git repositories. Lakshita, are you available on the call? I think you should be able to give us more information about the Git repositories. As far as I know, we haven't implemented that part of it yet. So Lakshita, can you shed some light on that?
Yeah, Kavishka. So what you said is correctly. So currently we only have implemented DB implementation, but soon, like with I think with the next release, we'll be releasing the GitHub implementation as well. So currently, if you want to use a Git implementation, you might have to do a customization and add a new extension. So what you have to do is, like, we have two interfaces, and then those are in our Carbon API repository, and then you have to implement those two base interfaces, and then change the retriever in the configurations, and then you can use it.
Hope we answered your question. Okay. Do we have any further questions? If not, so we will end the session for today. So the next session will be on the 10th of December, Thursday next month. So you can click on the community call page link to get notified of the next call, or submit any of your topic suggestions. So you can join our ongoing conversations on WSO2 App Manager using our Slack channel. Our Slack channel is actually very active. I see a lot of customers asking a lot of questions on our Slack, and you will always get a reply from a team member from our team. So we have our Twitter handle as well. So you can follow us on Twitter, and you can email us with your issues at dev@wso2.org. So you can find out more about our product by visiting our YouTube channel or our website. So you can also find the recording of this community call and this session on our YouTube channel. So you can go ahead and have a look at that as well. Since we have no questions, I think we can end the session for today. Thank you very much for joining the session today. And we hope you join for our next community call as well. We will notify over Slack and Twitter how we will, what topic we will be discussing and the agenda per se. Have a safe day and wish you a very good night.